So welcome again today, folks. Again, this is Armand Pantalone, the Chief Technology Officer at Giga-tronics, and I want to highlight some of our products today. As part of our TEmS talks, if you remember threat emulation system, we're going to show you a couple other key components of some of the ways to replicate threats in the RF world and some of the hardware that enables you to do that. So what we'd like to highlight today is the Compass systems, the Coherent multi-channel playback and acquisition streaming service. And one of the key components of that is the RF playback and generation system, which we highlighted in a different series of videos. The one we're going to highlight today, that's the other part of Compass, is the capture system. The RF playback and generation is obviously the RF playback system. So what we'll show you today is the capture part of it, and that particular product is called CEDAR. The Coherent Electromagnetic Data Analysis and Recording System, and we'll show you what that looks like.
This is just some of the software that enables the capture and the playback. This particular set of software enables us to capture the signals and also to analyze and display them in near real time. And the hardware we're going to show you on the right that is actually a stack of 4 separate channels of capture and 4 separate channels of playback. You just have to have those 2 PC workstations housing your PCIe-based capture and playback cards, the AVs and VAs, in the same form factor.
So what we'd like to show you today is not only a couple of the displays on the capture system, but also some of the ways we can capture the data and display it. And we're going to show you a couple different types of RF inputs to be captured. One of which is actually coming from our RF threat emulator, and another one of which we'll be putting into the capture system from the playback system. So we'll put some signals into these 2 capture channels in a minute. I just wanted to show you a couple of varied displays. We have a time domain display, an FFT, fast Fourier transform frequency display, and then this particular one is a persistence display, which you guys are all familiar with. Another history in time display is also the spectrogram, which gives you amplitude versus frequency versus time. And in just a second, we'll turn on the RF threat emulator, which is actually going to put a signal in to be displayed and captured. So the first signal we're going to introduce to be captured, analyzed, and displayed on the CEDAR capture system is actually going to be coming out of our RF threat emulator, which we've done a series of videos on as well. That particular system is perfectly compatible with our capture and playback systems. This particular system has the digital waveforms that are created to IF to be upconverted by our RF upconverters. That intermediate IF frequency is actually at 1200 megahertz with a full 1 gigahertz of instantaneous bandwidth. And what we'll do is we're actually going to cable the output of that RF system at the IF pulses into the capture system and show you what that looks like. Okay, if you've seen some of our other threat emulator videos, you may recognize this scenario, but we'll just kick it off right now, and then we'll first show it to you on a spectrum analyzer and then into the A to D capture card. There's the platforms and the emitters flying through the canyon. There's the pulse density and time. There's the RF on a 20 gigahertz spectrum analyzer. And we're going to go look at the signal first on an analog spectrum analyzer, and then we'll put it into the digitizer card. So what you see here is the center frequency of 1.2 gigahertz. With this particular scenario, has a number of different modulations. It has some frequency shift keying. It has some linear FM chirps in there, and it also has a significant number of pulse CW. So you'll see the usual sine X over X curve at 1200 megahertz. Now the next thing we'll do is we'll disconnect this signal and we'll put it into the digitizer card. So this is what the IF output before the RF up converter on the RF thread emulation system looks like, going into the A to D digitizer card as part of the CEDAR capture system. We can zoom in on any of these spectrum displays. Do some match holds to show you the modulations, and the same for the histogram of amplitude versus frequency versus time. We can change our resolution bandwidths. You can see the greater spread in the frequency shift keying and also the linear FM on the spectrogram display here. You can also see the 10 megahertz strip that just happens to be on one of the emitters in the scenario. So I realized I neglected to tell you about some of the functionality and performance of the CEDAR capture. And that particular A to D is actually capable of sampling at 6 gigasamples per second. To be compatible with our system, which has a 1200 megahertz center frequency and some 1200 megahertz LOs going into our RF up converters, we actually use that as a clock reference for the 2400 megahertz and the 4800 megahertz. So we actually sample the A to D slower than it's actually capable of to stream the data to the solid-state drive RAID array that are hosted in the PC workstation that also hosts the PCIe capture cards and also the PCIe playback cards. So we, again, run it at 4.8 gigasamples per second, even though it's a 6 gigasample per second A to D. And what we're going to do now is we're going to do a 45-second capture, turning the RF thread emulator on. We're going to capture 45 seconds at the beginning of the scenario, and we'll show you what that looks like first on digital playback and then on RF playback. And we'll also show you the capture, the fidelity of the captured signal by playing it back into the spectrum analyzer and see if it lines up, overlaps with the original thread emulator going directly into the spectrum analyzer without it being digitized first. So what we're going to do now is we're going to start a 45-second capture. I'll run over and throw the RF output on from the thread emulator. We'll let the 45-second capture stream the data continuously to the solid-state drive RAID array, and then we'll show you what the file looks like, and then we'll go through the exercise of showing you the fidelity of the capture. So I'll start the capture. I'll start the RF thread emulator. You can see the signal being written to the drive. There's about 15 seconds of the 45, and it's already 140 gigabytes written. This is the folder on the solid-state drive RAID array where it's actually writing the streaming data. And in about 5 seconds, it'll finish the capture. Very good. And 45 seconds is about 213 gigabytes written at that 4.8 gigabytes per second rate. And what we'll do now is we'll show you that captured signal capturing the output of the RF thread emulator, both on a digital playback and then on an RF playback. So what we'd like to highlight now is the ability to do a digital playback of the captured waveform file. As you can see running in the background right now, this is the live acquisition screen, and there's no RF input to the A to D and all the FFTs for display because I've shut off the RF thread emulator RF input to the system. So I'll stop the live capture, and I'll actually go to my playback mode, and I'll load a snapshot record of the first 30 seconds of the 45 seconds we had captured And you'll see when we play that back digitally, it will look like what we captured, which is the RF is off at the beginning, and then we go right into the scenario of all the pulse CW, the frequency shift keying, the linear FM outputs. So here's the RF actually off at the beginning of the scenario until I turn the thread emulator on. And there's all of our RF. You can see on the counter that we are in the 30 seconds of the capture that I had done. And then it'll just recycle. And you have controls for fast forwarding, going back to the beginning of the digital playback. So there's a lot of other features I'd like to show you, but to keep it short for today, even though it's not short just yet, there's so much else to show you, but we'll show you in more detail on subsequent video series of the same capture product. But what we'd like to show you is one of the proof of the pudding is, can we take the digital signal that was captured and turn that back into RF that looks just like the original? So we'll do that really quickly. The captured file we just done, the 45-second file with the RF off at first, we're going to actually grab that digital file and play it back with our RF playback and generation system. We'll put it first into the spectrum analyzer to show you that it does in fact line up with what we had put in from the RF thread emulator, and then we'll also show you what it looks like back into the digitizer. So when we go to grab the digital captured data and put it into our RF playback DAC card, it should recreate the input signal that we had shown you earlier in the series of videos straight out of the RF thread emulator before we captured it with the digitizer. So what we're going to do now is we're going to leave the capture software and go to the playback software, and we're going to grab the actual captured file that we had just done on today's date. The 213 gigabyte 45-second capture is what we'll play back. And when we hit start, we'll show it to you how it looks on the spectrum analyzer. So there's our 45 seconds worth of the beginning of the scenario. And the RF playback from the RF capture lines up perfectly with the original input to the spectrum analyzer on trace B from the original RF thread emulator input to the capture card. Okay, so another thing we want to show you up to this point, we've just been showing you some narrowband pulses around 1200 megahertz, pulse CW, some low frequency shift keying, and some small chirps. What we want to show you now is its inherent capability. It's truly a wideband capture system, so let's put some really wideband signals into it. So the first thing we're going to do, we're going to put in a synthesized 1 gigahertz instantaneous bandwidth single pulse chirp into from the RF playback system into the RF capture system, and we're going to show you what that looks like. So we're going to call up that file, and we're going to play it first into the spectrum analyzer to show you what it looks like on the spec am. There's your 1 gigahertz chirp centered at 1200 megahertz. And we're going to put that into the capture system next. Okay, so I've taken the RF playback of the 1 gigahertz chirp centered around 1.2 gigahertz, and I'm going to put it into the second of the A to D channels in the CEDAR capture workstation. So no signal in. I'm going to start the playback. And here is our 1 gigahertz chirp centered around 1200 megahertz on the second A to D channel. And then just for fun, what we're going to also do, just to show you the pushing the limits, we're going to actually play back a 2 gigahertz instantaneous bandwidth chirp into the capture channel. So this particular 2 gigahertz chirp is still centered around 1200 megahertz, but it's varying in a single pulse from 200 megahertz to 2200 megahertz, pushing the limits of the A to D, running at 4.8 gigasamples per second. So what we've shown you today is actually just a small subset of the capability, both functional and performance, of the Coherent electromagnetic data analysis and recording system. And we've also shown you the fidelity of the digital capture by showing you the fidelity of the RF playback. So in another series of videos, we'll show you a lot more complex functionality and performance to include 2-channel synchronous capture, 4-channel synchronous capture, and how the hardware we put together enables that to happen. We'll show you a little bit more in future videos of the inherent capability between the wideband capture and the wideband playback system. And hopefully you'll come back for that. As always, I just want to remind you folks that we are professionals, so please don't try this at home.